All right, in this question, we're trying to determine the molarity of ions. So the goal of this question is to move from a molecule that's ionic or an electrolyte to determining the ions, because in colligative property type questions, what matters with affecting properties of a solution is how many particles there are in the solution. So if we have something that breaks into ions, there will be more particles. So it's not grams of a solution. It's not even necessarily moles of a solution. That is important if it's a non-electrolyte. But when we get to electrolytes, it's how many moles of ions. And so this question is asking us molarity of ions. It tells us that we have a 0.620 molar solution of calcium hydroxide. The key with determining does it have ions is, does it start with a metal? Right, we'll see more, we'll dive more into this with acids in the future, but for right now, we're looking at, does it have a metal? Yes, calcium is a metal. Calcium is a 2+. This subscript here is a 2, that we have 2 OH minuses. So what we see is before we put this in solution, we have these calcium hydroxide solids that are bonded together, and they make this lattice structure. When they go into ions, those break up, right? So now we have calcium with 2 hydroxide. So each box becomes 3 particles. So the molarity of the ions, so if we have 0.62 moles per liter, the liters do not change, but what we do see, so moles of calcium hydroxide multiply every 1 mole of calcium hydroxide has 3 moles of ions. So the molarity of the ions is now 0.62 times 3, so 1.86 moles of ions per liter. So the molarity of our ions is 1.86. There we go. Okay, so basically multiply by how many ions. This is also known as the Bandt-Hoff factor. How many ions are going into solution? And the predicted for this would be 3. If it's not exactly 3 for some reason, because it's a weak electrolyte, it doesn't all dissolve, you would be told what I is equal to, how many it does break into. So you might see some questions like that.